Okay, so today I'm going to deal up with the very important topic, which is what is angular acceleration. Angular acceleration is basically acceleration of a body in a circular path. For a while, consider that this is a picture and this is a center point, which is also known as position vector. A line is drawn from a center to this point, and the velocity vector is drawn from here, which is tangent to a circle. So the acceleration, angular acceleration always acts in the direction of the velocity. Angular acceleration is nothing but this is tangential acceleration. Don't ignore it for a while. Acceleration is nothing but change in velocity. When the magnitude of the velocity changes by equal amount in the equal interval of time, or maybe unequal interval of time, but the magnitude changes in either direction or magnitude, the acceleration is produced. So let's deal with it. What is angular acceleration? Let me delete it. So what is angular acceleration? I have read all things. So what is angular acceleration? Let's use this pen for writing the angular acceleration. Now we have discussed that what is the formula of acceleration. So acceleration is equals to change in velocity. Acceleration is equals to change in velocity upon time, right? So angular acceleration is equals to alpha is equals to change in omega upon time. This is basically a formula of angular acceleration, change in omega upon change in time. So this is a formula of angular acceleration. So basically there are two type of angular acceleration. Now I'm writing here the two type of angular acceleration. One is instantaneous, right, and the other one is oof, and the other one is average. One is instantaneous and the other one is average. Now what is instantaneous? Let me write the formula of instantaneous acceleration. So let's write it. Instantaneous. Let's write the formula of instantaneous acceleration. We know that the instantaneous acceleration is equals to alpha is equals to omega upon t, where time dt, d omega upon dt, where time tends to 0, which means the acceleration is acting on a body. This is pretty obvious, but for a very short interval of time, or for a very for the instant time, right? But what if we talk about average acceleration in the angular variable? So this is alpha is equals to delta omega upon delta t, right? It is delta omega upon delta t, means final omega minus initial omega divided by final time minus initial time. So this is basically an average angular acceleration. And if the direction of the theta, which means that the displacement and no, the direction of the omega and alpha is same, which means that the velocity of a body increases and they are acting upon the same direction. But if the omega decreases, which means that the acceleration and velocity is acting upon the opposite direction, right? So let's see that and discuss the further details. Right. Let's move up. Okay, for the 9-year form, I need a pen. So let's see. Right. For example, we know that in the linear formulas, we have seen that the uh, velocity is equal to dt upon dv, in change in displacement upon change in time. There we have deal with it, and then we put something which is called integration, something like this. So that we have learned that the area under the velocity time graph give us displacement, right? Same is for the angular acceleration as well. The area under the angular velocity time graph give us what angular displacement, right? This give us angular displacement. This is something like this. And the area under the linear acceleration is equals to dv upon dt. I'm sorry, this is dx. dv upon dt. So the area under the acceleration time graph gives us velocity. This is for the angular acceleration as well. Alpha is equal to d omega upon t, which means the area under the angular acceleration and time graph gives us angular velocity. So this is something, this is the basic point that we need to understand before dealing with it. So now I'm going to talk about what is the SI unit of omega. What is SI unit of alpha, or the angular acceleration alpha, or angular acceleration or angular angular acceleration is radian per second square. But sometimes, as I said, that the radian does not appear because the supplementary angular does not have any unit. Radian per second square. So the its unit is also 1 upon second square. What I have written on no radian per second square, or it can also be written 1 divided by second whole square. So this is basically a SI unit of the alpha angular acceleration. Oh, I have done a lot of spelling mistakes. Then you can do it. Okay, for describing it, I need two circles. Okay, let's do that. Before moving ahead to discuss this circle, let me just tell you here. Let's take this green color. This is basically a formula. OMG, it's not visible. Okay, I'm gonna take the other color. Okay, so this is d omega upon this is d omega upon dt. Okay, which is angular acceleration. The angular acceleration is alpha uniform circular motion that we'll be dealing as well. This is angular velocity, angular acceleration. I'll be dealing each and everything in detail. So let's see it. For example, this is a point. This is a point of axis, center of axis. This is the other point. Okay. Now I have drawn a velocity vector from this point. This is a velocity vector v. We know that the acceleration is always acting in the direction of the velocity, something like this. Acceleration always acting in direction. But now I'm not dealing with it. We are dealing with something else here. We know that for a while consider that this velocity is angular velocity, right? So I'm going to draw this picture again. So this, you have understood this thing, how it is acting in the same direction. So let me read it. Oops, I need circle again. Okay, so let's take this pen again. For example, this is something like this. I know maybe I'm not making the perfect picture. For example, we know that the velocity of a body can be known by right hand rule. By right hand rule, what is mean by right hand rule? Which means that rolling your fingers in an anti-clockwise direction in this direction, and the direction which your thumb point out is the direction of the velocity. For while consider that this is the direction of the velocity, right? The velocity is by omega, and if your velocity is increasing, which means your acceleration vector and velocity vector is acting upon the same direction. Your velocity vector and acceleration vector acting upon the same direction, which means they are parallel to each other and they are parallel to the axis of rotation. But if this, for a while consider here the body again. Now I'm drawing dot. I don't know, the picture is not perfect. So now I've drawn a picture here, something like this. This is the direction of velocity, but now the velocity of a body is decreasing, which means now it means that the acceleration and velocity are in opposite direction. This is a way of knowing the direction of the acceleration, in the opposite direction. They both are acting in the opposite direction. That's because the velocity of a body is decreasing at this point, which means that they are anti-parallel to each other. If here the velocity vector is acting out of the page, then the acceleration vector must be acting inside, invert the page, right? Or the inside, in the direction of the page. So this is the way of finding out the direction of the acceleration, right? So let's erase it and now discuss the very basic concept.